Okay, here's a quick video for how to graph absolute value functions in my absence. Absolute value, if you remember, is the thing where you plug stuff in and you've got these walls here, and the absolute value takes the stuff inside the walls and makes it positive. So in this case, if we plug in x equals -2, we would write 3 times the absolute value of 2 times -2 plus 5 plus 4. So I just replace the x with the absolute value of -2. Then from here, I just start simplifying. This is the same as, my son thinks this is funny, 3 times -4 plus 5 plus 4, which is really 3 times 1 plus 5, so no, -4 plus 5 is 1 plus 4. Now, since this is positive already, we don't change the sign. We just do 3 times 1 is 3, and add 4 to get 7. Had it been negative, had this been a -1, it would have become positive, and it still would have come out to 7. So absolute value of 1 becomes 1, absolute value of -1 would also become 1. And we're going to take this process and do it with whole functions now. So just like how when we graph lines, we could plug in numbers for x and see what came out for y, when you graph absolute value functions, we'll plug in numbers for x and see what comes out for y also. Always plug in the numbers from -5 to 5, which I know seems like a lot, but it goes pretty quick. If I plug in -5 to the absolute value, come on Lincoln, quiet down. If I plug -5 into the absolute value of -5 is 5. Yep. I'm going to have a 5 here. And the absolute value, stop it. And the absolute value of -4 is 4, and 3, and 2, and 1, and 0, and then 1, and 2 again. Now the table that I can work with can only go from -5 to 2. It only has space for 9 spots. But I would also go 3, 4, 5. And if I take those points and I graph them, I plot them over on the graph, on the grid, just click and drag like this, it forms this V shape. Because for a while, the stuff that was negative became positive. I plug in -3, I get out +3. But if I plug in stuff that's positive, it stays positive, and it actually graphs like this. Every absolute value function graphs with this V, some corner down here somewhere. This is just your plain old basic absolute value function. Here's another one. I'll do f of x equals negative absolute value of x plus 3. Now remember, f of x and y just mean the same thing. So if I plug in -5 for x, I do -5 plus 3. And -5 plus 3 is -2. Sorry, 1 second. So I'm plugging in the number -5 for x. We'll actually type this first one out. So become negative absolute value -5 plus 3. That's when I plugged in a -5 for x. So what I'm really doing here is f of -5. I plug -5 in for x and see what I get out for y. This looks pretty weird with all these negatives, but I do -5 plus 3, which is -2. So it's negative the absolute value of -2. Well, the absolute value of -2 is just 2. Oops. So it all comes out to -2. This becomes a +2. This makes it negative. So it's -2. I plugged in -5, I got out -2. You can just trust me that it's going to go -1, 0, plug in -2 for x, -2 minus 3 is -1. The absolute value makes that +1, so there's a 1, 2, 3, 4, 5. Oops, sorry, these are all negatives. Let me see if my computer can graph this one also. It can. It can't. Come on, graph it. Come on, graph it. I do this. Nope, so I'll just plot those points. There's going to be a point at negative 5, negative 2, way down here, at negative 4, negative 1, at negative 3, 0, at negative 2, negative 1. It's going to go like this. It forms another V, but this V is facing upside down. And it's facing upside down because of the negative out in front. So anyways, all this to say, you take your function, you plug numbers in for x, you evaluate, and you plot. Not my best video, but we'll have to live with it. Thank you.